Welcome to The Explainer. You know, in education, we're just surrounded by new tools, new theories, and some really big promises. But how do we actually know what works? Today, we're diving into the numbers, the powerful methods that researchers use to separate the real facts from fiction inside the classroom.
So, think about a question like this. It sounds simple enough, right? But how can we be sure? I mean, really sure. How do we get past the marketing hype and our own gut feelings to find solid, hard evidence? This is the central challenge in education, and to tackle it, researchers have a very specific set of tools.
And that main tool is called quantitative research. It's basically a formal process for turning what happens in education, things like using an app or taking a test, into numbers. By doing that, we can measure things systematically, we could spot patterns, and we can test if one thing is truly having an effect on another.
Now, to really get a handle on this approach, we kind of have to see it in context. Because in research, there are really two main ways to go about finding answers. Think of them as two different lenses for looking at the very same problem.
So, the first lens, quantitative, is all about measurement. It's asking, how many students passed the test? Or by how much did their scores go up? The other lens, qualitative, asks about the experience. It asks, why do students feel more confident now? Or how are they actually interacting with this new app?
You can see the goals are totally different here. Quantitative research usually grabs large, random groups of people to test a very specific prediction. The whole point is to get a result that you can generalize to a bigger population. Qualitative research, on the other hand, goes deep. It uses smaller, carefully chosen groups and rich data, like interviews, to really explore complex ideas. And it's so important to remember, one isn't better than the other. They're just built to answer completely different kinds of questions.
The philosophy that drives quantitative research is something called positivism. A great way to picture it is to think of the researcher as a fisherman standing on a riverbank. They're keeping their distance, watching the fish from afar to spot patterns, objectively. The goal is to measure and analyze without getting in the way or influencing what's happening.
But the qualitative researcher, the interpretivist, they do the exact opposite. They dive right in. They're swimming with the fish. Here, the goal isn't objective distance at all. It's getting that deep, subjective understanding from the inside out. They want to know what it's really like to be a fish in that river.
Okay, so we've got the philosophy down, but how does a quantitative researcher actually, build a study from the ground up? Well, just like an architect, it all starts with a really clear blueprint.
And the cornerstone of that whole blueprint is the research question. You can't just ask something vague like, do apps work? It's way too broad. You have to get super specific. So, a researcher might start with a big idea like digital tools, then narrow it way down to a gamified math app for third graders. And finally, they'll draft a very precise, testable question about how that app affects test scores compared to, say, old school homework.
Once you've got your question, you make a formal prediction. We call that a hypothesis. But here's the really clever part. For statistical testing, you actually create two of them. The first is the null hypothesis, which basically assumes there's no effect. The app does nothing. This is the default position you're trying to prove wrong. Then there's the alternative hypothesis, which is what you actually think is going to happen. The whole point of the study is to find enough evidence to confidently say, nope, the null hypothesis is wrong. All right, the blueprint is set. Now it's time to pick the right tools for the job. And that means choosing a research design that can actually answer the question you're asking.
And believe me, not all designs are created equal. A correlational design is pretty useful. It can show you if two things are related, like maybe more time on an app is related to higher test scores. But, and this is a big but, it can't prove that one caused the other. For that, you need the gold standard, a true experimental design. That's where you randomly assign some students to use the app and others to a control group. That's how you isolate the cause.
And this right here is one of the most important rules in all of research. Seriously, just because two things happen at the same time, it doesn't mean one caused the other. The classic example is that ice cream sales and shark attacks are correlated. They both shoot up in the summer. But eating ice cream doesn't cause shark attacks. A third thing, hot weather, causes both.
So you've picked your design, but what about your measurements? Are your tools any good?
They've got to be two things. First, reliable. That just means consistent. Think about a bathroom scale that gives you the exact same weight every single time you step on it. That's reliable. But it also has to be valid, which means accurate. What if that super reliable scale is always 5 counts off? A valid tool measures what it's actually supposed to be measuring. You absolutely have to have both.
Okay, so you've designed your study, you've collected all the data. Now for the really exciting part. It's time to crunch those numbers and see what story they have to tell. This is the hunt for the aha moment.
When you analyze all of that data, you might find something that's statistically significant. Now that sounds fancy, but all it really means is that the effect you found is super unlikely to be just a random accident or a fluke. There's a really high chance that it's a real pattern. But that's not the end of the story.
Because a real effect might be so incredibly tiny that it's completely meaningless in the real world. And this is the huge difference between something being statistically significant and being practically significant.
Just imagine a huge study of thousands of students finds that a new program raises test scores by 0.2 points on a 100-point scale. Because the study was so big, that result is statistically real. It wasn't a fluke. But is it practically significant? I mean, would a school really spend thousands of dollars for a gain so small you can barely see it? No way. This is why the most important question is always, okay, but is the effect big enough to actually matter? Now, this whole field is changing at an incredible speed. The way we gather and analyze all this data is being totally transformed by technology, and it's opening up a whole new frontier for understanding how we learn.
Think about it. Every single click, every answer, every second a student spends on an online platform, it all creates a digital footprint. And this new field of learning analytics is all about harnessing this massive trail of big data. So instead of doing these one-off studies, research can become this continuous, ongoing process. It lets us do amazing things, like personalized learning paths for each student in real time, or even predict which students might be at risk so we can help them before they start to struggle.
This new world of data has so much promise, it's incredible. But it also leaves us with a really deep question. As we get better and better at measuring almost every single part of the learning process, how do we make sure that we're using all this power to actually help individual students, and not just to make the systems themselves more efficient? That, right there, is the big challenge for the next generation of researchers, educators, and, well, for all of us.